Dear students, we will discuss how buffer resist in pH change. First of all, we should know that a buffer is a large reservoir of acetic acid and acetate ions. Acetate ions comes from sodium acetate. When an acid or H plus ions are added in this buffer, they will react with acetate ion. To give back acetic acid, and hence pH of the solution will almost remain unchanged. The reason is that acetic acid, being a weak acid, will prefer to remain undissociated, so pH of buffer is almost same. Simply हम कह सकते हैं कि बफर एक बड़ा रिजर्वायर है किस किस चीज़ का, एसिटिक एसिड का और एसीटेट आयनों का. जब H प्लस डालेंगे तो एसीटेट आयन H ले लेगा और एसिटिक एसिड बना लेगा. H प्लस कंज्यूम हो जाएगा, pH चेंज नहीं होगी. और जब आप बेस OH नेगेटिव आयन इसमें डालोगे तो वो एसिटिक एसिड से रिएक्ट कर जाएगा. OH नेगेटिव H ले लेगा एसिटिक एसिड का, वाटर बन जाएगा, pH चेंज नहीं होगी. अब देखते हैं. When acid H3O plus or H plus is added, then acetate ion accepts H plus to form acetic acid. Acetic acid, being a weak acid, remain undissociated and pH remains unchanged. अगर एसिड डालोगे इस बफर में जो सोडियम एसीटेट और एसिटिक एसिड का है, तो एसीटेट आयन H प्लस को वसूल करेगा और एसिटिक एसिड बना देगा. एसिटिक एसिड कमज़ोर एसिड है और ये रहेगा अनडिसोसिएटेड ऑलमोस्ट, इसलिए pH चेंज नहीं होगी. व्हेन अ बेस OH इज एडेड, देन OH will get H plus of acetic acid to form water and generate acetate ion in solution. H2O has no effect on pH of buffer, therefore pH remains constant. इसका मतलब बेस डालोगे तो वो एसिटिक एसिड का H लेके अपने आप को कंज्यूम करवा देगा. इसका मतलब ये हुआ, it means H plus and OH negative become consumed by a buffer and pH remains almost constant. सादा सा हम ये भी कह सकते हैं कि बफर के अंदर ऐसे कंपोनेंट्स मौजूद हैं जो H प्लस डालोगे उसको भी कंज्यूम कर जाएंगे, खर्च कर देंगे, OH नेगेटिव डालोगे उसे भी खर्च कर देंगे और pH चेंज नहीं होगी. लेट अस टेक द केस ऑफ अमोनियम हाइड्रोक्साइड एंड अमोनियम क्लोराइड बफर. दिस बफर कंटेन्स NH4 plus and NH4OH. If acid or base is added in it, there is almost no change in pH. Why? It is due to following reasons. When acid is added, H3O plus or H plus is added, ammonium hydroxide reacts with H plus and form NH4 plus and water. pH remains unchanged. जब एसिड डालोगे अमोनियम हाइड्रोक्साइड OH नेगेटिव H को दे के पानी बनवा देगा, pH चेंज नहीं होगी. When base is added, then NH4 ions accepts OH negative and form NH4OH. NH4OH is a weak base which remain almost undissociated, therefore pH remains constant. It means H plus or OH negative become consumed by a buffer, so pH remains almost constant. Now we see that how pH remains constant of a buffer. Consider a buffer containing HA weak acid and A negative a salt. This is a buffer. HA and A negative, 2A negative, 3A negative, 4A negative. And HA, 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 HA4. Add H plus. four A negative are there, one A negative gets H plus and will change into HA. Now there are A negative, A negative, A negative decreases. A negative decreases, but weak acid is produced, so pH remains constant. It means addition of H plus to a buffer, the salt component A negative will consume H positive. If OH negative is added in a buffer containing H and A negative, then OH negative is neutralized by the H of HA to form H2O and pH remains constant. It means if acid is added in this buffer, H plus become consumed by A negative. That is a component of weak salt, salt of weak acid. And if OH is added, then OH become consumed by the H of HA, weak acid, HA weak acid. And OH become consumed, pH remains constant. When H become consumed, pH remains constant. Thanks for watching, subscribing, and sharing.